All right, Ryan, welcome to the show. Thanks for joining us.
Great to be here, Roger.
You and I have known each other since the seventh grade, and we have had conversations like this many, many, many times. Some of them are philosophically driven, some of them are scientifically driven, and you yourself have a fascinating trajectory. So, if you could walk back through kind of your history in particle physics and where it takes you today.
Wow, summary of career. Yeah, I was always really interested in physics and math. My dad was a software engineer, so programming became an interest, I think, early on. Yeah, I think I knew I wanted to be an academic even when I was in high school. Went to University of Texas for a bachelor's degree in physics. Then I went to Penn, where I studied for my PhD.
And were
Um,
you studying like a particular kind of physics? Like, are there different?
Yeah, you have to specialize.
Okay.
And even within particle physics, I'm an experimentalist. So
Hmm.
like there's a fork between studying experiment and theory. Initially, I still think I would have had a great time just studying theory because the topic itself is really interesting, but it takes quite a bit of hubris, I think, to be a theorist, to think that you're really going to push the envelope there. Whereas being an experimentalist, you can study the theory and pick interesting questions. And then what really makes or breaks things are how well you collaborate with others, how well you can use technology. Particle physics in particular, wow, we could like recap the history of CERN and what it's done, but like it helped started the World Wide Web like 30 years ago. A lot of internet technology is driven by particle physicists trying to collaborate around the world. Nowadays, it's very common for big companies, Facebook, Google, to have huge data centers everywhere, but like particle physicists really, I think, pushed that in the 90s and early 2000s, like what we think of as data centers. It was great training, learning from that community.
Yeah.
Um,
And why particle physics for you? And as opposed to any other sort of area of study.
Childlike questions, like why is the sky blue? Where'd the universe come from? Like anytime you just start asking why about anything, you can stop at different levels of explanation, but if you keep asking why, you get to like really interesting questions that's what drives the field in particle physics.
But for you, asking, you've just kind of continued asking the next question, essentially.
Yeah, and I think it's really interesting how much physics can inform that answer. It's not like there are a lot of things that you can just answer why. Like there is an answer to why the sky is blue. It's because of a phenomena called Rayleigh scattering. Yeah, there's a lot of things that are satisfying when you pull the thread and ask why, and realize how many people have already thought that before and written books on it. And
Yeah.
yeah,
And this, I think it's interesting that, that you kind of said, like, it's almost starts with childlike questions, right? Like, why are things the way they are? How
yeah,
did things settle into this position?
yes,
Why do we exist on Earth?
yeah.
How did Earth settle into this position? Physics obviously has answered many of those questions, still answering and unfolding a lot of new questions. For you, how do you see? I mean, this podcast is essentially it's about creativity and it's about creative thinking. What position or what role does creative thinking play in the scientific community?
I mean, I take creativity as meaning coming up with a unique way of seeing something or things like contributing something different that wasn't there before. But let's take that as maybe you have a better definition, but let's work with that one. And yeah, I think that's like how you have progress. Like somebody has to have a different idea. So yeah, creativity is not just an artistic thing. It's a thinking outside of the box, being aware of the body of literature that exists is starting point. So you can't just say I've got the right idea without understanding what everybody's thought before and like where the holes are in it. I think creativity is very useful for scientists and involves asking how can things be more general, how can things be more efficient, what's missing, what isn't this community doing, what is the next step. And yeah, I think that's true in any career. Now that I'm not in academia, I'm in tech, and I think that still applies. I'm often trying to see among my coworkers what's really going to help things be more efficient, pull things along. And I see that as a part of creativity.
Hmm. Yeah. And I love what you said that, creativity is not just for artists. It's not just for what we traditionally call creative people.
Hmm.
And I think that, like me working as a commercial filmmaker, you would call me a creative person, but that's because I'm a creative professional, right? I work in a creative industry. But creativity and creative thinking is something that is definitely inside of all of us. It's a tool that we can all use no matter what the field, no matter what we're doing. There could even be a creative idea for something you might change around your house.
Yeah.
So I love that you pointed that out, and I think that's
Got a recipe for cookies.
exactly, yeah.
Anything.
Yeah,
Yeah.
anything. It really can apply to anything. And I think that the thing I want to emphasize is the importance of it, because kind of like you said, it's how we make progress. So even in science, even in something like particle physics that can seem regimented, it can seem extremely scientific, but sometimes it takes thinking outside the box to push the science to the next level, or just simply to ask the right question, which I think is really interesting. How did you go from particle physics to tech?
There's been many generations of this. What a particle physicist does if they don't get academia. For a while, everybody went into medical physics, which is still a great direction to go. I mean, like all of how MRIs and X-rays and PET scans, all of that is applied nuclear and particle physics technology. So that was a hot thing to go into, especially in the 90s. Then for a while, everybody was doing finance because of the computational and numeric abilities. The last 10 years or so, 20 years or so, though, everybody's become some version of a data scientist, which basic means a lot of things. But in private sectors, every company has more data than they know what to do with now. And understanding your customers, understanding even just how your products are used, calculating risks, all kinds of things involve having some chops and being able to look through a database and figure out what is interesting in that. And that goes into the name of data science in various terms. So I guess I'm at some level a data scientist, but then, for the last 10 years or so, I don't know where you start the clock. Deep learning has become this huge field, which is a flavor of AI. And I was starting to do some of that. In the last few years, I was at CERN in 2015 or so. I led a workshop on trying to learn how to use a deep learning framework called Keras. What is deep learning? Deep learning is basically using artificial neural networks, which have been around for decades, but at a much larger scale than people ever had before. A neural network is a kind of algorithm that is sort of roughly modeled after how neurons in the brain work, but you could just say it's a graph. It's a algorithm that learns how certain things are related and can often give you a summarized output from many things. And for a long time, computer scientists and researchers, I think, underestimated how much you could push that field. You see all the technological applications around us that have gotten so much better as far as facial recognition and apps that can recognize the song that's playing in the bar that you're in.
Yeah. Even the focus tracker that's probably in one of these cameras that identifies what a face is,
right,
and can stay with it.
Right.
That's interesting.
But like when we were kids, I remember in the grocery store, mom writing a check and the check getting scanned, and like it could read the handwriting, and like that was working in the 90s, and that was a kind of neural network. Even then, that was like it's what Jan LeCun got famous for. He's one of the main research scientists at Meta, but in the 90s figured out how to use neural networks to recognize handwritten digits.
Right.
And it's just blown up from there. And I've been trying to learn everything that I can about it for the last 10 years or so. I've been in a couple startups that make new kinds of computer chips, new kinds of hardware for running these big neural nets, both for use and for training them. That's the field that I'm in now.
Yeah, fascinating. So you're kind of building hardware essentially for artificial intelligence to run on.
Yep.
Okay. And then I just to like almost rewind it for a little bit, because AI is such a hot topic right now. I almost want to go back and cover some history, right? Like, why were we aiming at artificial intelligence? What's the goal, the general goal of AI, and where does it really start? And from my reading, you can kind of correct me if I'm wrong here, but it kind of starts with Alan Turing because he's sort of the one who asks the big question of like, can we get machines? Can we build machines to do logic and do reasoning? And what will our capability be in the future if we can do that? And then sort of, John McCarthy picks it up late 50s and kind of picks up the baton and keeps running with it and really coins the term artificial intelligence.
Yeah, great name drops, and that's a good place to start. The only thing I would say is Turing really formalized just computer science as a field. So it's not, it's bigger than artificial intelligence. Like Turing formalized in a mathematical sense what a computer program is and like abstractly what a computer is, but regardless of how you implement it. So what you call a Turing machine is what a mathematician would take as a definition of a computer, and it doesn't matter how you made it. It basically means that it has some tape of memory that it can read and write to, and a way to write ones and zeros and make decisions based on them. I can move the tape over and write another one, or I can erase that one and write another one, whatever, right? Like as long as I can write ones and zeros and do some very basic processing, then it's what's called Turing complete. And that means that you could, in theory, really implement anything, and any computer, anything that what would be called a computer program. And so that's what Turing is prescient in seeing early on, this generality that like and or kind of logic could really open the door to implement really anything. And so I would say that's Turing's revolution. I think, of course, he did see AI as being something coming down the line. He's famous for coining this term called the Turing test,
right?
Which is sort of a line in the sand of pointing out that once machines are able to have a conversation at a way that's convincing, then it sort of blurs the lines of what people could even recognize as being intelligent or not, or artificial or not. So he's famous for that. But I'm just saying his career really formalizes much more general, just like what is an algorithm and what is a computer. And then you're right, I should have read some notes before we started this, but you're right to name drop McCarthy for coining the term artificial intelligence. And there's a famous conference, the Dartmouth Workshop is what it's called, in the 50s. And that's where people were really starting to get serious about talking about AI then. One thing that's very exciting now, living through this stage in AI, since I didn't live through these other older periods that we're talking about. Not only do I not see it slowing down, but there's just so many more people working on it than has ever been. Hundreds of thousands of researchers, maybe millions. I don't know. It depends on what you call a researcher, right? Like everybody is experimenting with AI now. So product engineers, average consumer is becoming more savvy about how to apply it. So I think it's a really exciting time now because I don't see much slowing down. I think more and more people are going to be creative and push things.
Yeah. And just because you mentioned the Turing test, and I think it's an interesting mention. I mean, we could argue, right? Large language models pass this test.
Actually, there's several papers that came out like in the last 6 months or so that claim exactly that.
Okay.
So that's why I kind of phrased it as a line in the sand. I would call it just like a pretty blurry line, and I would say we're stepping over it now.
Yeah. Okay. Yeah, that's interesting. When I think about the creative industries, when I think about like the future of creative workforce, I think this is the topic that I see a lot of people being sort of maybe apocalyptic about at times. Others saying, just something to add to the toolkit, not a job killer, I'm wondering from your perspective in the tech industry, when you're, hearing things, having conversations, doing things like building the hardware, where do you see artificial intelligence or AI's ability to impact creativity, like real. Maybe we can even differentiate, right, between something that's like human creativity and something that's creativity from an AI perspective.
The future is being enhanced by these tools, not trying to work without them. But the more optimistic way of looking at it is, well, just like with any technological leap, we can do things easier now, and so things you can prototype quicker, you can iterate quicker. Being hard-headed and saying I don't want the car, I'm gonna ride my horse is not the way to go, right? Like, accept that the car is the way to go. Accept that we can iterate now, and that's gonna benefit products, humanity, science, engineering, because the time it takes to go from idea to something that works pretty well is shrunk a whole lot, and
Right.
in many fields.
Yeah. And I think I see that in our field. I see that in the creative industries, in particular in commercial advertising. It's like maybe like concepting, ideation, formatting or templating certain things. Like we can get to product and idea faster, or we can communicate it easier if we're going to talk about generative AI, right? Like if I have an idea, the TV commercial we're about to shoot, I can use generative AI, right, to sketch it up, essentially. Give us some reference frames for how we want it to look, the angles we might film, things like that. So I do believe that right now it's really good at enhancing the process. It's really good at mimicking things that it can scrub the internet for. I would say the safety in the creative industries is that it is not very good yet at anything that is truly novel, right? Mostly because human creativity is, like you're talking about with a deep learning network, trying to mimic what the human brain is, which essentially is like originally the goal of AI, right, is to understand intelligence. Like, what do we mean when we say intelligence? If we can recreate it computationally, then maybe we can understand something more about ourselves, or we're kind of like, really, it's a question about us and understanding how are we intelligent? How does that emerge? What is that? What is that inside of us? But I think from the creative perspective, for us, right now, that's the safety in it. It's not really doing anything in my mind that's novel so much as it is just synthesizing a bunch of things out there that already exist, because it can scrub data and put some things together in some seemingly unique ways.
I think it's blurrier than that. I would push back and say, I don't know what humans are doing. I'm not a neuroscientist. I don't know what humans are doing, but are you so confident that what you're doing is any more novel? Don't you just learn by experience? Aren't you just a remix of the things that you've seen and read? Like I don't see a sharp line there. And I also think the way that we both train and evaluate cutting edge AIs now is still pretty narrow and brittle compared to the richness of the human experience. And that could change as AIs get more advanced and work in virtual worlds, especially, and then they'll experience a lot more rich things and then have that experience to draw from. See, right now, like when we're talking about these large language models, what have they been trained to do? There's many steps in the training, but the big bulk of it that takes so much compute that people call pre-training is literally reading through everything, all the text you can collect on the internet, reading through all of it, and just imagine putting a blinder on the book that you're reading, and as you're reading it, trying to predict the next word. So you're reading a sentence, but you're covering up what the next word is, and then given this context, what's the next word? And then it looks, and then if it got it right, it rewards itself. If it didn't, then it corrects itself. And then it does that as it's reading throughout text after text after text. And what's amazing about that is enough to force it to learn a whole lot of hierarchical knowledge about
what it's reading.
Yeah, that you can put eggs in a basket, but you can't put baskets in an egg, or just a whole lot of contextual knowledge about the world, right?
Right.
Because that's useful to be able to predict that next word.
Yeah. And in some ways, this is like why it was important for us to learn to read and write when we were young.
Yeah.
Because we're doing the same thing.
So definitely we're trained differently than how a human learns. Humans learn based on a lot less experience. Like we don't read the whole world's books.
Every book in the, yeah.
To be able to have all the knowledge that we have. And so
Right.
right now the frontier has been give it more, make it bigger. And it hasn't really slowed down. Like it has, like we've gotten better models that way.
Right.
But now we're approaching having like basically used all of the possible text that you can find easily on the internet. So we're not going to get a factor of 10 more written data to train language models than what we have now, which is why I brought up. And I'm not inventing this idea. There's a few important papers that have come out in the last few months that make this point that AI will be trained more with what's called reinforcement learning, which is more experiential kind of learning. Mm-hmm. Language models actually already get that kind of training at the later stage now, after we've finished all this pre-training that I talked about.
Yeah.
Then I've never been on a team that organizes this, but I've read about it. They RLHF refers to reinforcement learning from human feedback, and that includes chatting with the bot and then saying, I liked this answer or not. Right. And having teams of humans give that kind of feedback. So that's a small version kind of experience. But I think there will be more and richer kinds of feedback like that. Just like we're learning all the time in a feedback loop. It's not like your training is done and now you're done kind of, if you see what I mean. Like
yeah. And it will be the same for artificial intelligence.
Exactly.
I was thinking about us today having this conversation, for some reason, Douglas Hofstadter jumped in my brain.
GEB, yeah.
And his book, I Am a Strange Loop, I remember reading, and it made me, I ended up in the same place where it is like human experience. We are this strange loop, right? And we're constantly learning, we're constantly evolving. Now, that's probably one of the differentiators, right? We have all of this evolutionary stuff programmed into us, survival instincts that an artificial intelligence wouldn't have because it's not competing for resource, calorie intake, all of the things that kind of wired us up.
At some level, humans are a lot more efficient at being able to learn from very few examples and still have a very rich idea of how the world works. And I think that's an open question, like how much AI training can get better that way. A lot of people working on that kind of thing to make AI training more efficient. AI should be able to learn more with less data like people do, but the frontier hasn't been pushed that way.
Going back to the creativity thing, I think the differentiator at this point, I wouldn't argue that artificial intelligence will be able to get more advanced as far as like what it can generate when we're talking about like something novel, something truly unique. I think that humans are just better at it right now because, like you said, we're more efficient, for one. But number two, our neural network is so much deeper still, right? I mean, it's just the billions upon billions of neurons in your brain that synthesize together and can spit information back and forth to each other. And the fact that we can constantly rewire that continuously, right? Neuroplasticity, the ability to evolve it and change it. I think we are just extremely efficient and, in my mind, more creative because of that, because of our experiences being deeper. In other words, right now we're still messing with narrow AI. It's not general quite yet. Which differentiate between that?
The way I would think about the models that we have now is they aren't fully integrated brains like what a human is. They are parts of a brain, sort of like an organ or like the visual cortex. Something that makes it very concrete. A lot of one of the famous image recognition models that can say there's a cat or a dog in this image or also recognize your face. All of those models are what's called a feed-forward network. So there's a front of the model, and then there's a back that has a prediction or an answer, and data flows one direction through it, right? Like there's a camera or your eyeballs, and the signals get processed in one direction and then come to an answer, right? But that's what I mean by feed forward. That's important to contrast that with something that like ruminates or goes in a loop, like a strange loop. And I'm again not a neurosurgeon, but I'm sure there are parts of the brain, right, that are in loops and interacting in very complex ways. They're not just feed forward.
Right. Yeah, absolutely.
But your visual cortex, what little I know about neuroscientists, I think it is a feed forward network. Like when light comes into your eyes, it is processed in a feed forward fashion from through part of your brain, the visual cortex. And there's, I think, a lot of processing that happens at that level, including like finding edges and selecting out objects and maybe ignoring something that's not important and putting attention on something that is.
Right.
And all of that happens immediately in the processing of that without you like ruminating over it. So when I think about the artificial neural nets that we have, they're kind of like that. They're like the part of your brain that can, when you're driving, notice the obstacle and alert you of it because the signal just came in one way and all of that can happen quick. And your brain doesn't like cook on it to make the decision to hit the brake or whatever, right? But there's a few parts of your brain that come together to do that. But the visual part, I think, is just a one-way kind of processing. So think of them as very impulsive, these large language models. They're reactionary. They're picking what they think is most likely without given the context, which is hard for a whole human to appreciate as quickly as a language model can.
Right.
But it's not planning, and it's not like mulling it over like you might to make a decision.
Which makes sense because they're completely different entities, if you want to use that terminology, right? One's a human, one's not, one's a machine, it's a computer. A vastly powerful one, or a bunch of computers networked together, but that seems to be the clear difference there. This is an important question, and I think it's the question that concerns me more than any other question. What happens when you offset labor, and mental labor in particular? And I think there's a good example of this. There's some researchers who did a study on the impact of using things like maps every time we drive somewhere, right? So your brain is extremely efficient and it will adapt to what you're doing or not doing. And if you're not finding yourself, finding your own way through geographical...
lose that muscle.
Yeah, you lose that muscle, right? So the more we use maps, the brain gets a little bit smaller in one area because we don't really need that portion to be efficient. So with the language models in particular, when we start doing things like offsetting our reading and writing, we put that labor on something else. What happens to critical thinking? What happens to our own reasoning when we start having machines do more of this labor for us? I think that's the thing that concerns me more than anything.
That's a great question, and I agree with you. I'm scared for it too, especially for younger generations. Yeah, I think one way to look at it is we're going into the time where people don't write the words anymore, for better or worse, but somebody's got to read it, right? Like if
or a machine can and just give me a summary.
Sure, but what are you going to do with that, right? You still have to act on that information and make wise decisions, be informed, right? You and I would both agree having books on your shelves and having read them help inform who you are and help you make decisions. And the craft of writing a good document, be it an email, a report, a book, whatever it is an exercise in putting your thoughts down. And I agree that's the critical skill. As language models help us write more and more, yeah, I wonder how different younger people are going to think when they still have to read, but maybe they don't write that much. I don't know that that's a good thing.
Especially because they're reciprocating tools, right? I mean,
Yep.
Reading informs writing, writing informs your reading.
Yep.
They are kind of like one of these loops in a way.
Yep. And I think it's easy to sound like an old man who's back in my day we had to, but yeah, I
had
guess
to carry a book.
yeah, exactly. I guess I would encourage young people to try to do things by themselves, at least as an exercise. It's like lifting weights or something, right? Like, make sure you know how to, if left in a closet without your phone, without the internet, if you had a pen and paper, can you put whatever you're worried about, in some bullets?
Put your thoughts down.
Whatever you're interested in, can you be productive? Actually, just yesterday we had big thunderstorms in Texas and knocked the power out, and I still had work I wanted to get done, and then I at least opened up the pen and paper notebook and did some work that way. And I don't think that skill will go away. So yeah, I would challenge people to not always use their GPS, not always use the language model to plan your memo. Sure, it's going to help with some things, but I think think of it as exercise, like
Right. Yeah.
for the same reason.
I like how you put it. The same reason as like lifting weights. It's you're training another muscle. That muscle just happens to be your brain.
Yep. And especially if it's anything that you're obsessed with, and I think a lot, again, for young people, I think the most important thing when you're trying to get in any field is to get obsessed about something, because it's hard to force yourself, to get the 10,000 or 100,000 hours or whatever it takes to become an expert in something unless you're obsessed with it. So yeah, nurture your interest, figure out what you're interested in, and then try to build your understanding of it on your own, as much as you can.
Yeah.
Interact with AI, sure, but can you form your thoughts on pen and paper, I think is still very useful. Yeah, I think there is a lot to worry about people atrophying their abilities if AI constantly takes over a lot of work.
Sure. Yeah. And most importantly, I mean, in my mind, most importantly, mental labor. Obviously, it's going to take over all kinds of things. It's already taken over in many manufacturing processes. I've been in factories where forklifts are fully automated now, and they understand, like you said, they've been trained up on what are obstacles. What's a person walking in front of me? What's the difference between that and a big metal rack that still holds all the product that I'm headed to go get, right? Like all of these things have been trained. Now, some of that is good, right? Because physical labor is hard on our bodies. However, that does take away jobs. And the interesting thing I see here, at least in the creative fields, is that I think we're seeing an influx in many of the creative fields because as these jobs get automated, more and more people are going to pursue their creative passions. And I kind of hope that they do. Yeah, it's a good thing, right? It's like, I hope that is the case. And I think that's why I love what you mentioned earlier about creativity is not just for artists. It's really for anyone to do the same thing. Just exercise using that toolkit that's already within you more, and you become better and better at it as you do it. So as people enter the creative fields, even if they're interacting with things like artificial intelligence, just to augment the process, I think it's an interesting step or enhance the process.
At some level, we've lived through a similar revolution already, just with the internet coming on, right? Mm-hmm. Like the day and night difference between, having an argument in the bar about whatever, and now you can look it up and settle it immediately, right? And that's a generational divide that our generation gets, right? That like, of course I'm going to look it up, or of course, right? I should expect to be able to have this information at my fingers. Now we're in another step of that revolution where it's like, not only is the information accessible, but you should be able to organize it for me automatically, kind of, right? And it's in some sense, it's just another step like that, where being able to use that tool is going to help people in all kinds of careers if they master it. Just like, Googling is a skill that has moved, literally careers and academic research. And I use Google Scholar all the time, right? Like just to find papers. I imagine that will go away, and I'll have an AI assistant that just knows the kind of things I should read, right? Like, So it's, in some sense, it's incremental like that, but only if you're hungry to use it in the right way and still be pushing something new.
Yeah. And I think that's what's exciting about it from my perspective is when it enhances and when it can push things forward. And I think exercising your creativity on a platform like, let's call it just like a Chat GPT, or OpenAI's new Sora that's going to be coming out at some point, or any of these things. Mid-Journey was really big for a while, and a lot of people still spend a lot of time there.
Yep.
Generating these things, I think, boosts your creativity in a way where your imagination can come to life in seconds, and therefore your imagination will expand faster, is almost the way that I kind of see it at this point. What type of hardware are we typically talking about? You know, when you really break it down, like,
Yeah, good.
you know, your normal desktop personal computer, sure, it can interface with it, but what is the hardware that is actually operating this program?
Another way to phrase that is, why is NVIDIA worth as much as it is now? They were the front runner that happened to have this kind of technology and then recognize it and push it as far as they have. So the technology is GPU, graphics processing unit, and that comes from the original application having to do with computer graphics.
Sure.
And
yeah,
so
I mean, every computer in our studio has a beefed up set of GPUs in it because we do motion graphics, we do 8K video editing, all that stuff, right? You need lots of power. Yeah.
Yep. So abstractly now in AI, any kind of hardware that is good at this or tailor-made to do this is called an accelerator. So that's like not your main CPU, but it's a card like the GPU for your gaming machine.
Right.
You'll buy an accelerator card just for deep learning or just for processing these neural nets. Or maybe you buy servers that are just filled with these cards, you know, and data centers that are just filled with these servers.
Right.
It's that kind of scale.
Okay.
Yeah.
Interesting. And the accelerator and the GPU, same thing or different thing?
Same thing. I would say a GPU is a type of accelerator.
Type of accelerator.
Accelerator means a kind of computer for a certain task that it's like. So going back to Turing pointed out that if I just had tape and a thing that could write ones and zeros, I could process anything. So that's a computer, but it's clearly like not very efficient. And similarly, the general purpose CPU that's the main processor in your computer could do anything. It can run all these neural nets, but maybe not efficiently. So an accelerator is any kind of computer that's like, okay, when I run into this kind of computation, don't do it on the main CPU, do it on this thing.
Do it on the GPU.
Yeah.
Yeah.
That's an accelerator.
Okay. Yeah. That makes sense. I mean, from our perspective, obviously in video editing, we get to choose, like we go into things like Adobe Premiere, which is an editing software, and we choose how much percentage of the GPU it can tap into versus other programs that are operating simultaneously.
Sure.
So essentially that's what I'm choosing. I'm choosing how much can I accelerate the task or multiple tasks usually for my computer when I'm doing like a large video edit that has music, motion graphics, color, all this stuff already applied to it. It's a lot of processing power that's needed. So essentially, interesting. Yeah. And so what you're saying is the hardware that you work on is essentially striping together a whole bunch of GPUs and accelerating the hell out of something like a large language model.
That's what we're trying to do. That's right.
Interesting. And is that kind of product in the future going to be something that is desktop, do you imagine, for, you know, consumers? Obviously, only large companies, probably governments, are buying very expensive, loaded down servers with all these accelerators in them right now. But I would imagine that in the future, one day, I would be able to purchase something like that.
I think this is a great question, and I don't want to be recorded like making a prediction on it actually, because like you could have said, and people did say very dumb things about the PC, right? And like who's gonna need a PC in their home, right?
Yeah.
Back in the 60s, 70s time period, right? There was mainframe computers that weren't even that powerful from our point of view, that took up huge buildings and only weird geeks worked on them.
course.
why would you ever want a computer in your house?
Sure.
So I think it could be very similar like that.
Somewhat similar situation, right? Like, why would any individual need so much computing power in their living room?
Exactly. And then another way I would look at it is we're kind of already there, right? Like you just said, you have GPUs here. You're going to upgrade them to use whatever the latest thing is in 10 years, and it's probably going to have AI in it. One way to describe it is just called heterogeneous compute, or like compute in different domains. There's consumer scale compute, there's enterprise scale compute. And I think AI will be in both.
Yeah.
Yeah.
Yeah, and I could see something like an enterprise scale compute being useful for a company like the company we operate, especially because we do so much post-production. So if there were, let's say, a whole bunch of accelerators linked together that can just blast through whatever I want to train it on, because it's got AI software in it, I could definitely see that being useful for businesses like ours. But in particular, obviously, large businesses, right? Like banks or any kind of sector that you might want to be monitoring something continuously. That
I mean, your Ring camera that's doing security has AI in it, and some level of processor running a neural network inside of it that's already here.
Yeah.
I think one way to divide up the use cases of AI just coarsely is it training or is it doing what's called inference? So inference means to just use the model as it is, versus we've been talking about the training workload a lot too. And that's what a lot of people think of when they think of the data centers doing a lot of big work, but the data centers are also running inference at scale now, right? As everybody and your mother starts chatting with these bots all the time, right? That's inference being used over and over at scale.
Right.
Another way to think about it, I would say, is, are you talking about in the data center or on the edge? Is the way tech people refer to it. So the edge means like the Ring camera that you have, or the AI that you have in your phone.
Right. Yeah.
It's out on the edge being used by a person, and not
the ChatGPT app on my phone. I'm on the edge using it.
Well, then it gets blurry, because is the AI running in your phone or is it running in the data center?
I would imagine it's running in the data center.
Right. So your phone's just talking to the data center.
Right.
So that's not the edge.
I'm just communicating with the data center.
But sometimes the AI is in the device, especially for, I think, a lot of camera
technology makes sense.
Exactly. You want the inference to be done quickly, and so the processor's actually on the camera or nearby.
Yeah, like the focus tracker in one of these cameras.
Yep.
Yeah, okay. That's interesting. Well, to kind of just like provide a summary and a question for you, I think, because from my perspective, at least my reading about artificial intelligence, let's call it, essentially in the beginning, it was about understanding what intelligence is as something in ourselves. We know that we have intelligence, and in the beginning, it seems like the question was really about, can machines have it? That was the general question that we used, like Turing might have asked, or McCarthy might have asked, when starting to like really talk about these things or theorize.
I don't think so. I wouldn't phrase it that way. I think
how would you phrase it?
I think they were just geeks trying to figure out what computers could do. It's not so sci-fi to recognize that if you just keep extending these abilities, you approach a kind of automation that people start to call intelligent. And just, to take some of the woo out of it, I mean, I think intelligence just means solving your goal, right? Like intelligence means like being capable of doing something. And we get more impressed the more breadth it has, or like the more flexible it is.
Sure.
And I think, I don't see any hard lines there. I see it as like just a extension of capability, extension of more general kind of things. And what makes these language models, I think, so interesting is that the domain of language is so general. Right. It's not just route the mail or calculate the area under this curve or something that's like very mathematical. Like, here's an algorithm just to solve this thing.
Sure.
It's like, answer this question, or like, complete this sentence, and it could be about anything. And then so like the domain of language is so large that I think it's very natural to call that kind of thing intelligent.
Yeah, and I like that you said take the woo out of it. I like the way that you phrased that and simplified the definition of what we call intelligence, especially in the context of AI. And then the other thing that I think is interesting, I like your kind of perspective on enhancement or augmentation, especially when it comes to the creative fields or what we call creativity. That perspective, I think, sometimes gets drowned out by a lot of the apocalyptic ones. That it's like, well, I'll never hire a writer again because why would I? I can just have chat write everything for me from now on. But I think there are so many things that still need to be ironed out, and there's so much when it comes to having taste and having novel experiences and having, real deep connection to things that, of course, we still need writers, and of course we still need interesting ways of telling stories and things like that. So I think it is more of an enhancement tool and an augmentation. For you, what are your hopes? Like, you personally, you work in the industry, you build the hardware. What are your hopes for the future of artificial intelligence?
Okay, it's very easy to just talk about the health applications. I'm not in medicine, but it's obvious to me medicine's going to be revolutionized by these technologies, already is. Google's DeepMind and their product AlphaFold, I think. I'm not a biologist, so I it's hard for me to even appreciate how monumental what they accomplished is, right? Like they hacked the protein folding problem. So I think we understand the mapping between DNA and proteins now. Yeah, you need to find the expert to explain that, not me, but it probably is going to create a million therapies and drugs, extend life, lessen pain, cure diseases. I don't think that's sci-fi to say that there's a lot of things coming down the pipe in our lifetime for AI. So yeah, it's very easy to be optimistic about just the applications of healthcare. How about self-driving? One of the riskiest things we do day to day is get in a car. I personally would love it if people would never drive anymore.
But overall, you feel like the hope for the future is that we will use these tools to basically make life better. Things will
Sure.
get more efficient, but in the long run, I mean, the idea is that hopefully we're becoming better people because of it.
As long as we still read and write.
Yeah, that's true. Well, thanks so much for coming on the show.
It's been awesome.
I really appreciate it, man.
I'm excited about this series. I want to see more of it.
Yeah. I'm excited about it too. We're going to talk to a lot of interesting people like yourself, and I think a lot of people are going to have great things to say. So I appreciate it. Our executive producers are myself and Jessica Kramer. Our producer is Giselle Saucedo. Our editors are Max Smith and Garrett Alloway. Music by Creators. I'm your host, Roger Peters. Thanks so much for tuning in. We'll see you next time.